everyone doing? Good, all right. I'm very excited to be here. You know, I got the chance to give this talk to politicians, got a chance to give this talk to media people, to people in education. And I talk about the technology stuff, but I can't go into too many details, okay? But here today we have a room full of developers, so I feel like we can go a bit deeper. What do you think? Yeah? Okay, let's do that. I'm wondering, how many of you have heard before about generative adversarial networks, GANs? All right. How many of you have heard about Google's BERT, bidirectional encoder representation from transformers? Okay, I see quite a few hands. Nice. So yeah, this gives me confidence we can go a bit deeper today. So what we were planning to do, I'm going to teach you a bit how to generate fake news. Okay? Who wants to learn how to generate fake news? Ooh, did not expect that. Who wants to learn how to detect fake news? Okay, good. So truth is that it's actually good to know both sides, right? Because if you want to detect, it's good that you know what are the techniques and how the people who are generating this are thinking. And also, if you want to generate, you want to know what are the techniques that are being used to detect, so maybe you can bypass them. So it's good to have a good understanding of both of them. So try to cover both sides. Because like the presentation says, it's an arms race, like a cat and mouse game, and you want to be on top of the techniques that are being used by the other side. So what I'll try to do today, I'll try to share with you a few of the examples from both sides and also talk a bit about what we're doing with AdVerif.ai. I'll talk a bit later about the project that we presented in EMNLP conference just a few weeks ago. And how we used natural language processing techniques similar to BERT in order to identify fake news. But first of all, maybe let's start with a little game I like to call real or fake. So let's have a look at this example. What do you think about this person? Is he a developer? Is he a data scientist? Does he use Python, Scala? What do you think? Well, the truth is all of these questions are irrelevant because this person does not exist. I actually took it from a site that's called This Person Does Not Exist. So some developer took a work by NVIDIA last year. They used the generative adversarial neural networks, and he trained it on a data set of celebrity faces. And he put all of the examples in this site, and like you can see here, the results are very, very realistic. Let's try another example. You guys know Bill Gates, right? So let's try this. I'll play 3 sound clips. Hopefully the sound would work. And let me know which one of these you think is the real Bill Gates. Okay?
A cramp is no small danger on a swim.
Pluck the bright rose without leaves. The glow deepened in the eyes of the sweet girl.
What do you think? Who thinks it's the top one? Okay. The middle? The bottom? Okay. There's definitely no consensus. Truth is, I kind of tricked you. All of these are fake. None of this is the real Bill Gates. So this was generated by a few guys from...
Pluck the bright rose without glow deepened in the eyes of the sweet girl.
So this was generated by a few guys from Facebook using a technique called MailNet. They took a few hours of TED Talks by Bill Gates, trained this model, and again, you can see the results are very realistic. And finally, so we saw an example with an image, an example with audio. And let's talk about text. How many of you have heard about GPT-2 from OpenAI? OK, I see quite a few. So we actually did this example with AdVerif.ai a couple of years ago. It was much simplistic than GPT-2. We used a recurrent neural network. And we trained it on a data set of news headlines. And we thought, wouldn't it be nice if we have a game where we have headlines both real and fake, and you need to guess which one of them are real and which one of them are fake? I think this link might still be live, so you can actually play with this. What do you think about this example? Is it real? Is it fake? Who thinks it's real? OK, and fake? OK, you got that one right. Yeah, but we're seeing more and more of these examples with images, example with audio, example with text, and it's becoming more and more realistic. Such realistic that Gartner predicts that with this wave of AI-generated fakes, also known deepfakes, this will become even a bigger problem. But let's first take a step backwards, see how all of this has started. So the last few years, we had very big advancements in AI, and especially with deep learning, and especially with one type of deep networks called GANs. And the guy here, you know this guy, Jan Goodfellow, rightfully named here the GAN-father. This is the guy who invented GANs. And GANs stands for Generative Adversarial Networks. Generative because they generate images, videos. Why adversarial? Because of their concept. So it basically, you take together two networks. One, the generator tries to generate an image or a video, and a discriminator who tries to detect if the image that was generated by the generator is real or fake. And then you put both of them in a kind of a battle. And you run through a lot of iterations, and both of them are getting better and better. And this is a really powerful concept. And you can search online for examples, beautiful GANs. You will see very, very beautiful examples. But as we learned from, I think, one of the comic books, we know that with great powers also come great responsibility. And we're starting to see what happens when these tools fall into the wrong hands. Which brings us to our next chapter about bad AI, how AI can be used to detect, to create fakes. Let's have a look at another example. What do you think? Realistic, concerning, interesting. So these things are becoming more and more realistic, but they are also becoming more and more accessible. So these kind of things, you don't need to know any coding. You can use, like they used in this example, a simple webcam and the software. But if this even doesn't work for you, maybe you could use an app to create fake news, which was the idea of the fake app. Out of curiosity, did anyone here try this app before? No? For educational purposes, of course? OK. So if an app is still maybe too complicated for you, what do you think about this idea? Imagine that you could take a video, take the text of that video, and just edit it, and it would appear like the person in the video saying what you made him say. So this was the idea of the guys here from Stanford.
In this work, we present the first text-based video editing approach that lets editors insert new text in addition to cutting, copying, and pasting the existing transcript text. Our approach allows editing at any point and synthesizes the corresponding correct, lip-synced video.
Okay. The market closed today with Apple's stock price at $191.45 per share.
Here we replace 91.4 with 82.2.
Okay. The market closed today with Apple's stock price at $182.25 per share.
Did you notice any difference? Did this seem out of place? So what they did here, they basically trained a network to map the lip movements to the sounds that they make. So it's basically an advanced lip syncing method. And it works quite well. It would be interesting to see. So in this example, it was very simplistic. It was just numbers. It would be interesting to see what would happen if you want to make it say something like a chimpanzee or I don't know. But still, these things are going in a very, very interesting direction. And talking about audio, let's look at another example.
Hey, Don, have you heard about this new technology?
Are you speaking about this new algorithm to copy voices?
Yes, it is developed by a startup called WeAreDevelopers.
This is huge. They can make us say anything now, really anything.
The good news is that they will offer the technology to anyone.
This is huge. How does their technology work?
Hey guys, I think that they use deep learning and artificial neural networks.
Hillary is right, and I can tell you that their team is great.
I wish them good luck. I'm sure they will do a good job.
Great for parties and fake news. Did you hear the story? It was in the news a few weeks ago about someone who used, I don't know if it was technology by this company or something similar, but a fraudster used audio-generated fake to get a manager in a company wire a serious amount of money to his manager after he received an audio message. Did you hear about this story? Yeah, I see a few hands. So these things could be used for political purposes or for just entertainment, but they also have very concerning applications. And we saw an example with video, we saw an example with audio. Let's talk again about text. We saw in the beginning the example that we did with AdVerif.ai a few years ago with the headlines. And there was the story that you heard about from OpenAI about GPT-2. You remember initially they didn't want to release the full version because they were concerned people might misuse it. I think a few weeks ago they actually released it. But there was a similar work by guys from the Allen Institute. And they put up this website. You can also check it. It's called Grover. And they took it a step further. What you can do is put in a headline, like a link found between autism and vaccination. And the machine will generate a complete story based on that headline. And you can even make it appear like it's coming from a specific source, like CNN or Reuters, or even from a specific writer, to make the style seem like the style of that writer. So, in addition to these examples, I want to mention that it's not all doom and gloom. Okay, so we are seeing a lot of malicious applications, but there's also some very beautiful applications of this technology. I don't know about you, but going back to my school days, this kind of text generator would have been very, very helpful with essays, right? Imagine you don't need to write anything, you just put the headline and the text generator prepares the essay for you. Would have been nice. But more seriousness, so imagine that you would go to Netflix, okay? You want to see a movie, I don't know what's your favorite movie. Let's say the Terminator, and you want, instead of Arnold Schwarzenegger, you want Sylvester Stallone to appear in it. Okay, so you would choose a different actor, and then the deepfake will regenerate the movie especially created for you. Or imagine that you really like to listen to podcasts, and you like the voice of Morgan Freeman. So it would make all the podcasts that you listen to from now on narrated by Morgan Freeman. How cool would that be? So there are some also interesting and very good applications. We just need to be aware about the malicious applications. And finally, if technology got us into this mess, maybe technology can also help to get us out of it. And this brings us to our chapter about good AI. So there are a few initiatives in the past few years that are trying to use technology to fight disinformation. There are initiatives by fact-checking organizations like Full Fact from the UK and Duke Reporters Lab in the US. There are initiatives by government agencies like DARPA. They are obviously involved. And there are also commercial initiatives like with AdVerif.ai. So let me ask you a question. Who do you think generates fake news? Russia? Okay, so that sounds like politically motivated. Any other sources? So it's not surprising for me to hear that, because not many people know that a lot of the fake news comes not just from political purposes, but just from, I wouldn't say greed, but for money, for monetary motivation. So it's also about a lot of guys who are just putting up a WordPress site, putting some sensational stories there, getting traffic from social media, and then monetizing from advertising. Okay? And you hear about these stories in troll factories and fake news factories in this country and other country. And what we're trying to do with AdVerif.ai, we're trying to remove this link between the advertising money and the fake news. So we're preventing ads. There are a lot of advertisers who don't want to be associated with this content. This is called brand safety, by the way. And we help them to prevent their ads from being shown in a problematic context, like fake news. And at the same time, it helps to get rid of this motivation, of the money motivation of all of these guys who are doing this for the money. Maybe they will move on to the next venture. So how are we doing that? We are using deep technology. I'll give an example in a few minutes. Another thing that is very important also is the subject matter expertise. Okay, a lot of the time we are developers, we find a shiny new armor, and then we're just looking for nails. But it's very, very important to be close to the problem, be close to the domain, think about the problem you're solving, and that's why we're working with fact checkers. These are people who, this is their profession. It's also not our job to decide what is fake or what is real, so we leave it to these people. And through these collaborations with fact-checking organizations, we're able to get data. Right? Data is important. If we don't have data, you cannot train any machine learning model. So we are using these collaborations to get models, to get data to train the models, and to get better performance. And we're doing quite well. We started last year a partnership with the EU versus Disinformation campaign. We won an award from CB Insights for being one of the global game-changing startups. And there are quite a few initiatives like that, initiatives that are trying to use technology to fight disinformation. So let's go a bit deeper and try to see a few examples of how technology can actually help us. So what I wanted to share with you today is a very, very interesting challenge, something we presented in EMNLP conference a few weeks ago. And the challenge here is interesting because there's a lot of work about trying to detect between fake news and real news. But try to think, how can you detect between fake news and satire? Both of them are basically not real. Is there any difference actually between them? And it's not just a theoretical question. It has a lot of important applications. So think about the social media. Okay, companies like Facebook are trying to demote disinformation. But satire is not something that you should demote, right? So satire is protected by freedom of speech. So then they come into this problem. They had to create a new flag for satire, separate from the flag from fake news. But then what would happen? What we already see happening, the fake news creators start to claim that they're actually satire. They put badges, like you can see in this side, that, with disclaimers saying that the content is satirical. So this brings this interesting challenge. Can we use AI to detect fake news versus satire? So we started to think, OK, what actually makes satire unique? What do you think? What is the difference between fake news and satire? Any ideas? Can you speak louder? Funny, funny, very good. So that's actually the main difference. Satire is supposed to be funny, entertaining. That usually has some irony, absurdity, supposed to deliver maybe some social message. So we came with two research questions. One, can we use semantic and linguistic use, I'll talk about this in a second, to try to capture this humor part, okay, of satire? And then can these nuances, can these features, the semantic features and the linguistic features, tell us more about the differences between fake news and satire than, for example, the language that is being used in the stories? So what we did, we came up with two methods. For the semantic part, we used Google's BERT. BERT, for those of you who don't know, you can think about it as an advanced word-to-vec method, okay, language model. Unlike word-to-vec, so word-to-vec is supposed to capture some semantic representation of words, such that the word king relates to the word queen, like the word man relates to the word woman, okay? But unlike word-to-vec, which learns a single embedding for a word, BERT learns an embedding that depends on the context. So the semantic representation is much more stronger, much more representative. So that's for the semantic part. And for the linguistic part, we used a text toolkit called coherence metrics. It has more than 100 indicators related to measures like text readability. I'll talk a bit about this in a second. And we use these two methods to try to detect fake from satire. But then, where can we get a data set that will allow us to train these methods? So luckily, there was already a previous work by guys who did the hard work for us. They manually labeled something like 500 stories between satire and fake. And what was very, very important for us, that they did this based on the story, based on the content itself, not based on the source. Saying, for example, that The Onion is satire and some other sites are fake. So they looked actually into the content and decided whether it's real or fake. And they also presented the baseline. It was a very simple baseline. They used the TF-IDF representation and a multinomial naive Bayes classifier. So then what we did in our work, we implemented the two methods that I shown before, the coherence metrics. This is the list of indicators of text coherence. And we used the logistic regression. And as a separate method, we used BERT to try to capture the semantic representation. When we compared it to the baseline, you can see both of these methods actually perform better than the baseline. But what is interesting, so you see BERT is achieving the highest performance. But you know, there's a lot of talk nowadays about explainable AI, right? So we want to know what are actually these differences. And BERT is doing a great job, but it's not very explainable. It's not very easy for us to see what is it doing inside. It's kind of like a black box. So luckily, we also used the coherence matrix method, and we looked into the indicators, trying to see which one of them are more supporting of satire and which one of them are more supporting of fake. And we saw very interesting things. So we saw that causal connectives that in some theories are proven to be related to text comprehension. And we also saw measures related to text readability. These are some indicators. If you hear, for example, sometimes that they say that the story was written at the 6th grade level, at the 8th grade level, 2nd grade level. So these are these kind of indicators about the text readability. And we saw both of them are saying that satire articles are actually less easy to read or more sophisticated than fake news articles, which is quite interesting. So this helps us to learn more about the differences between satire and fake. And what we also learn is that we can use AI to try to detect between the two. So this is an interesting example for working on text detection. Let's talk also a bit about video detection. I really like this example because it's borrowed from the forensic analysis domain. So what these guys did here, they shown that you can look at the video, focus on the face, and for a human face, you will see slight changes in the color as a result of the human blood flow. But if the video is computer generated, then you would obviously not expect that to happen. So that's kind of an important signal to try to detect computer generated content. The problem with these kind of things is that once you come up with the signal, you publish a paper about it, can you guess what would happen next? The generators start to use new methods that overcome this signal. So this is where the arms race really goes into motion. On that note, did you guys also hear about this the competition, the deepfake challenge? Yeah, can you raise your hand? I'm interested to know how many of you. Okay, not a lot. So Facebook, one of the main problems in this area, there is a lack of data sets that can be used to train this kind of methods. For example, you could use a machine learning method to differentiate between real and fake videos, and there's a lack of data that can be used to come up with this method. So that was one of the goals of Facebook in this challenge, to try to encourage people to work more on these kind of challenges. So we're gonna compete as part of AdVerif.ai. I'm curious if there's anybody in the audience who has experience with deep learning for machine vision. Please feel free to reach out, because we are looking for people like that to also help us compete in the challenge. I was planning to show you also an example that by the time that we got already, we did a very quick prototype, but I'll skip that so we'll have more time for questions and answers. Yeah, so what did we learn today? So first of all, we learned that deepfakes and the technology that is being used to generate them is becoming more and more realistic. It's also becoming more and more accessible. We saw an example with the fake app. We saw an example with the video that you can actually edit the text and make the person say something that he didn't say. At the same time, we know that there's so much content going around on the web, on social media. Probably by doing this manually, we will not be able to detect it alone. We will need also technology to be on our side. And we're seeing a few initiatives going in this direction. We saw examples how you could use AI for text detection using natural language processing. We saw examples for machine learning with image recognition to differentiate between real and fake videos. And before I wrap up, I would like to leave you with this question. How can we continue to advance this technology and make the best use of it, okay? Do we need politicians to help with regulations because they know about technology so well? Do we need people in media to educate people about these things, know that they exist? That probably wouldn't help, or probably would help a lot. Do we need technology guys like ourselves, developers, to think about malicious applications of the things that we develop, and maybe built in some defense mechanism? So there's no clear answers, and that's probably the answer should be all of the above should contribute to this. But these are the kind of questions we need to think about if we want to win the fake news arms race. Thank you.